Hi, I'm Lalit Vasist and you are watching Engineering Made Easy. Friends, in today's video, I will tell you what we mean by electrical resistance and on what factors the resistance of a resistor depends. In this simulation, I have a wire. This is a wire and the length of the wire is denoted by L and its area of cross section is denoted by capital A. The symbol that you are seeing here is called rho, 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 and it is the electrical resistivity or the specific resistance of the material. The resistance of the wire also depends on this resistivity. Okay, so let's see how the resistance of the wire depends on this resistivity rho, length L, and area of cross section A. I will vary these three parameters and you will see how the resistance changes. The value of the resistance you can see here. Okay, so R is equals to rho L by A. It means the resistance of the wire is directly proportional to its length and inversely proportional to its area. It means if I increase the length of the wire, then its resistance will increase, and on increasing the area of the wire, its resistance will decrease. You can see it from this formula also. Now we will know what we mean by electrical resistance. Actually, electrical resistance is something that opposes the flow of electrons in the conductor or in a wire. If something is resisting or opposing the flow of these electrons, then we call it a resistor. The opposite term of the resistance is the conductance. Okay, so now let's see how the various parameters affect the resistance. Here I will first increase the length of the wire. You see, initially the length is 10 centimeters, and on increasing the length, the resistance which is shown here is increasing. You see, resistance is increasing with length. You can also observe it that as I'm increasing the length, this is increasing, and you can see it also from the this formula that L is increasing, so R, the size of this R is becoming larger. You observe it. So with the increase in length, the resistance of the resistor is increasing. Okay, while on increasing the area, if I increase the area, you can see from the formula that if the denominator increases, then the R should decrease. So I am increasing the area, then you observe if I increase the area, you can see the animation, the size is increasing, the area is increasing, so the resistance is decreasing. Observe here. Okay, so what happens when we change the resistivity of the material? So this, if I change the specific resistance, so let's see how it changes. If I increase the resistivity, then the resistance of the wire increases, while on decreasing it, the resistance of the wire decreases. Okay, you can observe it here. So not only the resistance of a wire depends on its length or area, that is the physical parameters, but also on the properties of the material, the resistivity of the material. The inverse term of this resistivity or the specific resistance is the conductivity, which is denoted by sigma letter. Now I will tell you the physical significance of this formula of resistance, that is why on changing length or area of cross section of a wire affects its value of resistance. As I just explained you the definition of electrical resistance. Actually, electrical resistance is nothing but simply the opposition of flow of electrons of the conductor. Okay, if something is opposing the flow of electrons or the flow of current in a wire or conductor, then we will say that it is offering some resistance, it is resisting. Okay, so if I increase the length of the wire, so on increasing the length of the wire, the electrons has to travel more distance. Actually, current flows when there is a net flow of electrons in the wire. Actually, the direction of current, the conventional flow of direction of current is just opposite to the direction of flow of current. So actually I is dq by dt, the rate of flow of charge, which is electrons here, per unit time. So the rate of flow of charge is the current. So if the electrons are flowing, then the current will also flow. If I will increase the length of the wire, then the electrons will have to encounter more collisions with the lattice structure, the structure various ions, okay, and other electrons also. So there will be various collisions while they are flowing through the conductor. So on increasing length we will see more collisions and more obstacles in the flow of current. That is why on increasing length the resistance of the wire increases. The opposite happens when we increase the area of cross section. This is the area of cross section of the wire. On increasing the area of cross section of the wire, the electrons get more space to flow. That is why there are less obstacles or collisions while moving through the wire. So less hindrance is offered and less resistance is offered by the wire. So this is the reason why on increasing length the resistance increases, while on increasing the area of cross section the resistance decreases. The material of the wire also responsible for the resistance of the wire, because we know the current flows because of the number of free electrons, okay, that are flowing. If any material has more number of free electrons, the electrons are loosely bounded to the atom, and on applying just little voltage, then the electrons are broken and they offer the flow of electrons and current is observed in the wire. More number of electrons are released, the more amount of current we will observe. So definitely different materials have different number of free electrons and different bonding of electrons. So the specific resistance or the resistivity of the material, which is also an important factor for the resistance of the resistor. If any material has low resistivity, it will have more current with the same length or area, and if any material has a higher resistivity, it will have low current. Okay, so in this way we saw that resistance of a resistor depends on its physical parameters, length and area of cross section, and also on its specific properties, which is called the resistivity of the material. You can also observe that if we increase the temperature of the conductor, if something is a good conductor, then in that case the vibrational energy of the lattice will increase and more number of electrons will be released. So because of this we will see more collisions between the electrons and more collisions with the lattice structure or ions present in the wire. So on increasing the temperature of the conductor, a good conductor of metal, we will see increase in its resistance, which will reduce its flow of current. But this is not the case in case of semiconductors or insulators. In case of semiconductors and insulators, on increasing temperature the resistance decreases because there are already less number of electrons. On increasing temperature more number of electrons are released, which further increases the flow of current. Since I is dq by dt, so more charge is flown per unit time, so the ultimately the current increases. But in case of conductors, good conductors, there are already enough number of free electrons, so on increasing temperature it gets congested. Okay, there is crowd of electrons, so which ultimately causes hindrance in the flow of electrons. So instead of increasing the current, it causes reduction in current because of increase in resistance. So friends, now you know on what factors the resistance of a resistor depends, and I think you found this video interesting and useful. If you found it really interesting and useful, then please click on the like button and share it with your friends. And for more such interesting videos, you can subscribe to my YouTube channel Engineering Made Easy. Thank you for watching the video till the end. See you soon in the next video. Till then, bye bye and take care.